All right. So picking up just where we left off, you can see that our last example is just above this. I wanted to do another one of these, number puzzle style ones. These kind of give us the cleanest equations, even if they're maybe a little bit less. You're not gonna like open up the hood of a car and one of these word problems just like this is gonna fall out, right? Something kind of pulled from the real world. We'll have to maybe do a little bit more reasoning to work with. Anyway, this stuff is all fine. So let's read it right. 10 more than double a value gives an amount 4 less than the original value. Okay, so sort of 10 more than double a value. So a value here, right? This is going to be our variable. This is our x, right? So gives an amount. Gives is going to mean equals, right? And I guess I should do some of the other numbers here, right? So from the first half, you kind of get what I like to do when I'm doing these is the equal sign splits it really up into two different halves, right? So 10 more than double a value, that's like the left side of this equation. So 10 more than, right, would be 10 plus, right, plus 10. Double a value, doubling is multiplying by 2. So this is sort of a 2x plus 10. Or 10 plus 2x, the ordering there again, because addition is commutative, the ordering there is arbitrary. So gives, right, means equal. So an amount 4 less than the original value. So again, the original value, the value there is just our variable x. And 4 less than, right? 4 is obviously 4. Less than is subtract. 4 less than means you're starting with the value and then you're subtracting 4 away from it, right? So that's going to be x minus 4. So the ordering there with the subtraction, always a little bit tricky. Making sure you get the ordering and the subtraction not necessarily the same as the sort of, the math order won't necessarily match the sort of order of the language. What do we have to do to solve it? Well, this is pretty similar. This is not all that different from the one we just did as an equation, right? The one in the last video. The idea, right? What did we end up? 20 minus x equals 8 plus 3x. So it's sort of one number term on each side and one variable term on each side. We essentially have the same setup here. What do we need to do to solve it? Well, let's get the x's on one side. Let's get the numbers on the other. So in this case, I've got 2x here and sort of 1x here. I would rather subtract the 1x from both sides, right? So let's get rid of the x over here. I've got then 2 minus 1 would leave me with 1x, aka x. That means sort of then to make this work, if I've got x's to the left, I need to do numbers to the right. So I'm going to have to subtract this 10 from both sides, right? So this is sort of 1x, right? The 10s cancel, equals negative 4 minus 10. So a negative subtracting sort of further away from it. 2 negatives here will get me just a larger negative, negative 14. So this is sort of x equals negative 14. And lo and behold, we did it. That's that. Typically, right, we would need to do a division if we ended up with, 3x, 5x, 10x, whatever in front of your variable. But we didn't here, right? We just ended up with 1x, which means we're done. We sort of get to the solution here pretty quickly, which is kind of nice for a change. Doesn't always happen that way. Let's keep moving. A little bit of a cow impression there. I want to look at some where it's maybe more of a classic kind of word problem style. And so we're sort of coming up with the equations a little bit differently. So I've got a problem kind of plotted out. Let's do, so 3, 5, right? Continued. So in the year 2019, I had 45 students earn an A or a B as their final grade. This was an increase So this was an increase of 7 from the number of A's or B's earned by my students in 2018. So the question is, how many A's and B's did I give out in 2018? So how many A's or B's did the students earn in 2018? So what's happening here, right, as we get into a little bit more of a real world style problem, it gets a little more wordy. Sometimes, and this is happening here, you get some numbers that you don't even necessarily need. And so everything gets a little bit more cluttered. So you have to be very careful about sort of pulling equations and different things out of here. The real work is all in the setup to a certain extent. Once you have the setup kind of like done and worked out, solving the equation is really the easy part, right? It's really all about the setup here. So let's run through this. So in 2019, I had 45 students earn an A or a B as their final grade. So okay, what's going on here? Well, maybe we're trying to figure out how many people had A's and how many people had B's, right? We're going to get some extra information about this, right? But, by itself, there's not really anything else I can do with just that first sentence. So 2019 is the year, right? 45 students sort of receiving these grades. So this was an increase of 7, right? So increase of 7, right, means plus 7. So just as far as like identifying some math stuff, so like that's some math stuff, that's sort of a number I should be aware of, from the number of A's or B's in 2018, right? So this 2018, or rather the 2019 value is essentially the 2018 value plus 7, right? So this is like, okay, 2019, like number is 2018 number plus 7 more. That's essentially what's happening, right? And so then the question is, how many A's or B's did the students earn in 2018? So the question I'm trying to answer is sort of, what was this 2018 number, right? And so the setup I'm going to use is actually what? Well, and I'm forgetting, of course, right, the piece of information I have from the very, very beginning, right, is that the number in 2019 is 45 students, right? So my 2019 number is 45. That's a value that I know. So the 18 number is really the one. The 2018 number is really my variable here. So my unknown is my X, is this sort of 2018 sort of total number of A's and B's. So what I'm going to do is sort of try to put all this together, right? So the 2019 number is, right, is of course means equals. So the 2019 number is 45. So 45 is my 2019 number, is equal to the 2018 number, which is my X, plus 7. That's a whole lot of work to just get 45 as X plus 7, which you're then going to solve in one step, right? The idea is, okay, well, then that means I'm just subtracting the 7, right, to get the X by itself. 45 minus 7 is going to be, what, 38? Right? So 2018, there were 38 students with an A or a B. So that was a lot of setup just to kind of get one very, very simple equation. But, that's how it goes. The real world is really about not necessarily getting a more and more and more complex equation. It's really about just sort of dealing with this type of thing where you have to just sort of like muddle through, okay, what does all this mean? How am I going to turn it into math? How am I going to turn it into equation and then sort of solve it, right? So it's all that stuff coming together here. And make sure we're answering the original question. So the question is how many, right, A's or B's do the students earn in 2018? So that's this value X. It just so happened that the sort of question we're answering is also the same as our variable. Solving for X then sort of answers our question. And in this case, it's just going to be a matter of, right, solving for this, which is sort of taking the 7 away and getting 38. This is a simple enough situation. You probably might even solve this, if we weren't in this class and you stumbled on this, you might be able to just solve it without even really thinking of it as an equation. You'd say 45 is 7 more than the number from the year before. So you'd say, oh, well, then take the 7 away, right? And you have the number from before. And that's true. That is what we ended up doing. So the math here and kind of maybe what your intuition is all kind of comes together. The other thing I'll note in this one is never at any point did we actually use the numbers 2018 or 2019, right? Neither of those numbers actually were used for anything. Those are the years, but that's really just sort of marking for us kind of situation 1 versus situation 2. It's kind of giving us the left and the right side of the equation. The fact that the year was 2018 or 2019 didn't have any impact at all. We never really used those numbers, and we didn't need to. It doesn't really matter what year it is. It was just a way for us to distinguish kind of, the year 1 versus year 2 in this scenario. I'm going to pause this video now, and we'll do another one that sort of continues in this same style to start video number 3.